Computer numerical control machines, popularly known as CNC machines, where a computer is used to control the machine tools, to eliminate the dependency on bulky and fragile paper tape procedure of NC machine. In other words, CNC machining is a process used in the manufacturing sector that involves the use of computers to control machine tools. This upgrade is necessary to manufacture complex curve geometries in 2D or 3D, and to machine components with high repeatability and precision. To improve production planning, and to increase productivity, to achieve close tolerances. CNC machining is often the last step in metal manufacturing, or sometimes the only process involved. Compared to other metalworking techniques, CNC machining is capable of meeting the tightest tolerances and producing the most accurate, precise products over and over again. The CNC technology is used in the different machining processes. Some of them are as follows. Turning machine. Turning utilizes a cutter that moves perpendicularly through the center plane of a rotating workpiece. The part shape depends on the shape of the tools and the operation performed to obtain the finished part. Milling machine. The milling process involves the use of a rotating cutter to remove material from a workpiece. The tool will be in the rotation, and the workpiece will be in linear motion. CNC grinding machine. A grinding machine is also called a grinder, which is used for grinding by using an abrasive wheel as the cutting tool. Each grain of abrasion on the wheel's surface cuts a small chip from the workpiece via shear deformation. CNC ultrasonic machine. Ultrasonic vibration of very small amplitudes drives the form tool of a ductile material. An abrasive slurry flows through the work area. CNC laser cutting machine. Laser cutting is a technology that uses a laser to cut materials and is typically used for industrial manufacturing applications. A focused laser beam directed at the material, which then either melts, burns, vaporizes away, or is blown away by a jet of gas, leaving an edge with a high-quality surface finish. Electrical discharge machine. In EDM, power supply controls the electrical discharges and movement of the electrode about the workpiece. During operation, the workpiece is submerged in a bath of dielectric fluid. As this course is mainly focused on CNC turning, so we'll discuss the CNC lathe machine in detail. CNC lathes are rapidly replacing the older production lathes due to their ease of setting, operation, repeatability, and accuracy. They are designed to use modern carbide tooling and fully use modern processes. CNC turning machine. The design of a CNC lathe varies with different manufacturers, but they all have some common elements or parts in common. Different mechanical parts in a CNC turning machine. They are headstock, chuck, tailstock, CNC lathe bed, tool turret, foot pedals. Headstock. The headstock of a CNC lathe machine has the main motor of the CNC lathe machine, which drives the main spindle. Chuck is mounted on this main spindle, which holds the workpiece and rotates it. Tailstock. The tailstock is mostly used to give an extra gripping force for component machining. For long components machining, they provide an extra force on the other end, so the machining process can complete smoothly. CNC lathe bed. The tool turret travel over the CNC lathe bed, which is specially hardened, so any kind of machining can't affect them. Tool turret. The turret that holds the tool holders and indexes them as needed. Foot pedals. Foot pedals are used to actuate the chuck and tailstock quill. Through these pedals, CNC machinists open and close the chuck to grip the component, the same way tailstock quill is taken to forward position or reversed through these pedals. Different electrical and electronics elements in a CNC turning machine. They are voltage stabilizer, machine controller, machine control unit (MCU), drive system, feedback system, servo motor, stepper motor, encoders. Workflow of CNC machine. Part program, program input device, machine control unit, drive system, machine tool, feedback system. First, the part program is inserted into the MCU of the CNC. In MCU, all the data processed takes place, and according to the program prepared, it prepares all the motion commands and sends it to the driving system. The drive system works as the motion commands are sent by MCU. Drive system controls the motion and velocity of the machine tool. Feedback system. records the position and velocity measurement of the machine tool, and sends a feedback signal to the MCU. In MCU, the feedback signals are compared with the reference signals, and if there are errors, it corrects it and sends new signals to the machine tool for the right operation to happen. A display unit is used to see all the commands, programs, and other important data. It acts as the eye of the machine. Applications of CNC machine in various industries, which are as follows: aerospace, machinery, electrical, fabrication, automotive, instrumentation, mold making, medical.